Alright, so here we're actually going to be talking about finding the equation of a circle, which is really just an equation that describes every single point along this circle. So I'm going to pick out a few points on here and think about an equation that can model how I can get to each of those points. Basically, how I can relate the x and y for all of those points. And it's really coming directly from this triangle. We'll see how it's connected to the distance formula. But for right now, it's going to look more like Pythagorean theorem because my center is at 0. When this center moves, it's going to look a lot more like the distance formula, and you're going to see how the radius and the center are related through this equation. So I'm almost going to pretend I don't have that. Let's say that was just c right now. So this is my a and b. I would use Pythagorean theorem as x squared plus y squared to find that c squared, that side. I'm going to set up a separate right triangle. Let's set up a right triangle over here. So I'm thinking about that side. It's somewhere in between. I can't really tell where that is, but I know that the radius is c. Actually, let's even do that. Let's replace that c with the radius. Same exact thing's happening here. It's going from the center to the outside. That's that same c in this right triangle. It's still the longest side in that right triangle, and it's still the radius of the circle. It's also the x and y coordinate of that point. It's a different x and y from there. This one looks like that's -3. This would be -4. And you'd see that that's going to still be that same. That's a 3 by 4 triangle. That's still going to give you the same radius. The radius doesn't ever change in this circle. So Pythagorean theorem really does model this directly. You can set up different right triangles inside of that circle and see that the x coordinate and the y coordinate are the a and the b in that triangle, where the radius is that c. So this is the standard form of that equation. I'm going to clean this up a little bit. The standard form is x squared plus y squared equals the radius squared. Here the radius happens to be 5, and I'm actually going to square that. So x squared plus y squared equals 25. That is the standard form of the equation of that circle. You see that the radius is always going to be there. Actually, I'm going to write the general form here. The x and the y coordinates are always on that side, just like in Pythagorean theorem, and the r is basically replacing the c because it is the longest side in that right triangle that we're setting up each time. So you're going to try to find the equation of that circle. Again, it really is that same form each time. When the origin is our center, it's not any more complicated than that. You're just going to take that radius and plug it in. And actually, you do want to solve that exponent and simplify it into just one number rather than an expression there.